So hello everyone. So today we will review the contents of the different sessions that we had so far, and in between if you will have some doubts you can ask questions, and it is a kind of quick glimpse of the journey that we had during these 7 sessions. So in the very first session we talked about what it means by learning. It was actually the experience from past and the differences between the humans and machines, how they perceive the environment, and how machines are different in taking decisions, how machines take the input from the entire outside world. It is through the sensors, through different other sources of data. So we understood this, why machine learning, where it is actually absolutely necessary to replace a human. That is what is the need for machine learning, and humans' intelligence of responding to the learned task is translated in machine learning through different mechanisms. And we talked about the details of machine learning and artificial intelligence, machine learning being one domain of artificial intelligence where we try to mimic the learning ability of humans in machines. We talked about intelligent system and several existing intelligent systems in the very first lecture. We were discussing examples through vehicle recognition, fruit recognition, and face recognition kind of applications. We understood the attributes and their significance. Then we tried to understand the difference between the traditional algorithms and machine learning algorithms. Can you recall what is this difference? Yeah. Is there any problem in voice, or is the voice audible? No? Others, are you getting my voice? Yes. So many places it is coming out to be a yes response. Can you please check out your system? If you restart, I think you will be able to get the voice. Yeah, some people are not getting. So can you please try and check it out at your end? Fine. So the question which I asked, what is the difference between traditional algorithms and machine learning algorithms? So there is one answer. Input and output is given to machine learning algorithm and programmed. So you're close to the correct answer. You actually work without a program, just based on the basis of X and Y pair of input and output given to this algorithm. Your program tunes itself and the parameters are evolved, and that is what we say that a program is generated through input and output. So in machine learning, what you have as the input is the input-output pair, and what is your output? It is the program. While in the traditional algorithms, you have the program and the input while you produce the output, right? So in some sense, you are creating the program. So data and experience served as input to ML algorithm, which produces program as output. This is absolutely correct. So in traditional algorithm, it is just input and program receives this input and it produces the output. This is also clear. So somehow you see the difference between the algorithms which are traditional and the algorithms which are machine learning based. Even though both of them are capable of getting executed by your system. The system may have a single processor or it can have multiple processors. What machine learning algorithms are giving, they are producing certain parameters which then are used for training, and then you are picking up the output as a consequence of executing the machine learning program. Of course, both of these programs run in the absolute sequential way as your traditional programs would be executed, machine learning programs would also be executed. But in machine learning programs, we do not have to give such kind of if and else conditions which we actually would have given in the traditional program. If it is a function, in traditional programs, we would have given the function equation. While in machine learning, the function equation is not given, but only x and y pairs are given, and the equation is generated based on those data sets. Okay, so you need to go through the complete lecture details and see what else you could take from those lectures. Then in the second session, we had regression. We talked about training and testing in learning systems. Then what it means by prediction, what it means by training and what it means by testing, X and Y as input-output pair. Then you try to understand the error in regression problem solving. Can you recall what it means by the error in the context of regression? Yeah. Can you recall what it means by an error? So it is the difference between predicted value and actual, and then you square the difference in order to nullify the minus effect and take the sum over all the observations. So here the cost of the error, or what you can say is that the error is minimized for best hypothesis, right? So what do you mean by the best hypothesis, Nathan? It is the description of the line that may fit the given data such that the error is minimum, right? So that is what is the best hypothesis. The error correspondingly to this hypothesis would be minimum. Okay. So then comes function approximation. So we actually talked about one example, had x and y pairs and tried to see which function would be the best to get approximated to this data so that we can have the prediction for any unknown value of x in the most appropriate sense. So basically you understood the best hypothesis and the minimum error trade-off through that discussion. Then we took the slope and the intercept to define the hypothesis, the line fitting, of course, in terms of those two parameters, and you understood what it meant by squared mean error. Okay, so go through the corresponding lecture and see the details. In the session 3, we had decision boundaries and regions. You can recall what makes classification different from regression. Can anybody suggest the answer? Should it be only discrete versus continuous? So, anyone else? What is the difference between classification and regression? So in regression, you try to approximate a line or a curve to the given data, while in classification, you try to approximate a decision boundary that separates the data belonging to two classes to the best possible way. So in classification, we have the separability as a concern. In regression, we have the approximation as a concern, so that a given line or curve fits the given data. That is what is in regression, right? So you can also understand that in regression you are predicting a value. In classification you are predicting a class label. Okay, so then we talked also about binary classification, uh, then linear separability. What do you mean by linear separability? You have to look at the data belonging to two or more different classes, and you have to represent each data belonging to a class as a feature vector. This feature vector may be two-dimensional or it may be multidimensional. We have talked about the feature vector also. And correspondingly, if suppose n is the dimension of the feature vector, if you visualize each observation to be plotted in that n-dimensional space, you will have to see that the points belonging to one class should be separable from the points belonging to the other class using a line. If that is the construction of this input space where we can separate the two data sets belonging to two different classes, then we call such kind of separability as linear separability. There are instances where the data is not so linearly separable, right? Because of its proximity to some features with the other class. So in that case, we will have to see that the decision boundary is a kind of non-linear boundary. In that case, we will say that the data is not linearly separable. If at all, there is no possibility of picking up a linear boundary in between. Okay. Yeah. So Navdeep, are you not able to get my voice clearly? Is it okay now? Okay, fine. Okay, so we continue with this. Then we talked about the discriminant functions in which we tried to understand the equation of the boundary in terms of y equals mx plus c kind of formulation where we took slope and intercept as two parameters. We also discussed these slope and intercept as W0 and W1 kind of weights, which you have already understood, and then you understood that the hypothesis took the form as x2 minus mx1 minus c. So you can always say that if test data, if I'm saying test data is, let us say, xt, then after having acquired the values of m and c through your training data, if you try to compute this f of xt, where xt is the test data, using this equation, of course it will have its own x1 and x2. If you find that this is greater than this 0, then it should be lying in one side of the boundary, and if it is less than 0, it will be lying on the other side of boundary. So depending upon this kind of scenario, you classify that test sample. Okay. And you can understand that here this C is basically coming out to be a kind of threshold beyond which your data is belonging to another side of the boundary, and if the complete value of this computed hypothesis for xt, if it is less than 0, you will have the data belonging to the other class. And you also saw the process of identifying the decision boundary on 2D plane. If you have different samples, let us say some samples like this, and you have a different class whose samples are somewhere lying here and there. Okay, so I'm just trying to draw. So you can see that the best possible way of drawing the line would be to draw it either this way, right, a line this way, or this way. So you can see that their slope or intercept may differ, and both the decision boundaries are correct, right? So both the decision boundaries will be considered as correct because they are able to separate the training data. And tomorrow, if you have a test data coming out to be falling in the input space, let us say here, you will definitely see that the hypothesis H has its value greater than 0 or less than 0 to see that it belongs to one of these classes. So this kind of understanding we try to discuss and inculcate in those classes. Okay. Then we had discussed classification algorithms, and in that session we could discuss only these two classifiers, k nearest neighbor and naive based classifiers. You understood k nearest neighbors as a lazy learner algorithm. Then you understood the meaning of k, right? These are the nearest k values, and then out of that, whichever largest class representation you get for the test data, you assign that class to the test data. So we had discussed at length the process of classification using k nearest neighbor by distance based weighted KNN algorithm, where distance based weights were calculated as the reciprocal of the squares of the distances. Larger the distance, smaller the weight, and then correspondingly you picked up the samples from one class and computed their overall weights. And even despite large number of representation, if their total weight was less, we would assign the class to the test data as the one which is represented by larger weight, irrespective of the number of the samples which are closer to test data. So please revise this lecture and understand the computations. Then we talked about Bayes theorem, naive Bayes classifier, did some problem solving, classified test pattern. So this itself was a complete discussion. So I would recommend that you should go through and learn all the aspects. Then in the next session, we were talking about decision tree and data visualization. We talked about decision trees and their limitations, why attributes play significant role in deciding the decision tree based classification, why they are contributing in reducing the tree length, what it means by leaf and non-leaf nodes of a decision tree, what is it meant by information content, the entropy of the given set of observations. This is about their decision-making ability. So you counted on the yes or no decisions and then computed the probabilities. Then you computed the total entropy or the information content. Then you looked at the attributes splitting capability by computing the gain and remainder computations. If the remainder part comes out to be the least, or in other way, if gain part comes out to be the best using a particular attribute, we place that attribute at the root level, and accordingly the remaining ones are computed, and their splitting capabilities were tested using gain and remainder computations. So this problem we had tried to discuss in that session. Then it was followed by the data visualization tools, where I had shown you some Python programs. Of course, in this mid-semester test, there will not be any question revolving around the Python program, but as a concept and as a kind of generic definition of scatter plots, parallel coordinate graphs, Pearson correlation coefficients, etc. You are expected to know these definitions. Then in the sixth session, we talked about the feature engineering. So machine learning model with feature engineering was a little different from what we had been talking about. Here we were doing a lot of work on feature analysis, finding out which features would suit to our application, and then it had been taken as a basic pre-processing step to the machine learning model. Then dimensionality reduction, then feature extraction techniques, and especially the major focus of this session was on text-based features, in which we talked about bag of words, TF-IDF, right? It actually was a very established technique. That is why we discussed this for text processing, what it means by n-grams, what it means by stemming. Um, Anybody can recall what it means by stemming? Yeah, Pawan, I will come back to your question a little later. Yes. So changing words to standard words. Stemming is about changing the words by removal of the suffixes like ing or s. So what it means by, played, playing, and plays, every word will count towards play. So it is basically the term frequency computation in which we do not treat these type of words separate. Okay. So image features, we talked about several transform based features. Of course, I suggested that most of these transform based techniques will be more thoroughly known to you if at all you go through a course on digital image processing or you work separately on the transform based techniques, because it is really a very dedicated task to understand the transform based features, right? Um, so we had a glimpse of transform based features, but we focused on the text based features such as TF, IDF, and other things. So then we just had a reference of feature selection algorithms as principal component analysis and the other technique about forward selection and backward elimination. Of course, we could not find sufficient time on that day to discuss more in depth the feature selection algorithms. We will see if in future there is sufficient time available for us to discuss feature selection algorithms, then we will discuss. But as a part of this session, you should have sufficient idea about what it is actually for feature selection available. These are just two algorithms. However, the research domain is full of feature selection algorithms, right? Yeah, feature selection algorithm, yes, basics, that is fine. Okay, I have even given the reference for forward selection algorithm. If you are willing, you can go through that to know how feature selection is done. Okay. So then came the last session in which we talked about how to evaluate the classifiers. We also talked about how to take the data for training and testing. We discussed the partitioning of the data using these three techniques: hold out, cross validation, and bootstrapping. Then we talked about the class-wise accuracy. Of course, bias and variances were also discussed to check out whether they are going to contribute in the overfitting or not. Then we discussed true and false positives and negatives, precision and recall. This also is a measure of evaluation of classification model, sensitivity analysis, ROC curves, and confusion matrix. So your any machine learning project, whether you do it as a dissertation project or a project in your own organization, any machine learning project without such kind of evaluation techniques is incomplete and its performance is not predictable. So always try to include sensitivity analysis, ROC curves, confusion matrix, etc. in your analytical content of your dissertation project if you pick up machine learning as your base technique. Fine. So this was all we discussed in the pre-mid semester classes. So the mid semester syllabus comprises of all these lectures that we had till today, and now I am leaving the questions for you, and of course I will take your queries. Yeah, so you can have some questions to ask. Before I would take Pawan's question, the difference between clustering and classification. These are the two methods which we use in machine learning or in data mining very heavily, because we are discussing the belongingness of the data. If we have sufficient information about the labels of the classes, so that whatever we have in hand can be used to predict the class of the test feature vector, we put that kind of problem in the classification domain. But if we cannot, or if we do not have the labels in hand of the data which is being used for training, then we can simply go on bringing together this data automatically by clustering. And there is no name given to it, because nobody has supervised what this object could be. It is about not knowing what it was, but it appears to be similar to something which I had seen yesterday, right? It could be, place where I had gone earlier, and I saw the scene which is similar to the scene which I saw yesterday, but it is exactly not. I don't know what scene it is. Or if you can recall the Mars rover, you know, somewhere it is moving around and it is collecting those features, and it is just trying to put together everything by clustering, though it doesn't know its name, what this object is. Probably it found some stones, similar looking stones. Tomorrow it finds another, sized stones. So this puts in two different clusters while not giving this a name. So clustering is without label and classification is with label, right? So clustering, you do not have the label, and in classification you have the label. Is it fine, Pawan? Okay. So any more questions? Hypothesis, yeah, these are the two words, hypothesis and decision boundary. These are the two words are used for defining the, separator boundary between the two class samples. So hypothesis is just a general term which is also used for the line that best fits the given data in regression. So hypothesis is just something which is parametric in nature. So you are defining it using some parameters. Well, decision boundary displays its own meaning. It is actually self-explanatory. Yeah. So obtaining equation of decision boundary if two data or vector is given. So Geetika, the question I'm understanding is that you want an example of obtaining equation of decision boundary. Okay. How would you get it? Suppose you have some data. Maybe I would write some data. So I think you can stop giving me questions, because I will first answer these, then I will take some more. Otherwise, I would be simply losing the questions track. Okay, so I'm taking some data. Let us say it is something like 10 and 20. This is one x1 and x2. This is one data, and its label, let us say, is class 1, or let us say class A. So then there is another data which is, let us say, 12 and 25, and its class label is A. Then there is another data which is 100 and 130, and its class label is B. And there is the fourth data item which is 100 or 90 and 120, and its class label is B. So if you try to plot these on your two-dimensional plane, what will happen? You have the values plotted like this. So let me write some values here and there. So suppose I'm taking this value 10 here. It is all actually manual. So what you know is manual, but if you write your code, that will have an automatic system to compute such values. But as a As a learner of machine learning, you are expected to know such techniques. Suppose this was 122 or 120. I'm going to just plot some values very arbitrarily, just to give you the idea. Sorry. So yeah, this one has to be 20, and this one is somewhere around 120. So what I am writing on the x-axis is these values, x1, and on the y-axis it is x2. Okay. So then how are you going to plot these values? So 10 and 20, this is one class. I am representing this class by green. The A class I am representing by green. Another goes somewhere close, 12 and 25 as its coordinate. And then I'm changing this color to blue and plotting 100 and 130 somewhere here, right? And 90 and 120 somewhere here, right? So this is the data. Let us say we have this data. You can clearly draw a line in between. How would you draw this line? Maybe from 60 or somewhere, or maybe 90. So this you will have to understand that your scale should be very well defined. Either you use proper scale to check out these values. So what you have here is, let us say this value starts with the intercept as 90 and it goes up to this 90. So it's A and B as the intercepts on x1 and x2 are 90, right? So what will be the equation of this line? What is this? What is the slope of this line? Can somebody tell? What is the slope? It is -1. Am I right? Right. So and what is its intercept? Intercept is 90. Okay. Intercept is 90. So how will I write my equation? It is actually x2 equals mx, right? So m and x1, m star x1. I'm deliberately not using x and y notions because you know that y is representing the class label now. So the dimensions are represented by x1, x2, x3, etc. Right? So this plus the intercept. That is what is the equation of line. Fit in all these values, you get, or rather you first define your h of x. Okay, this is equal to, or let me say this is actually equivalent to something as x2 minus m star x1 minus c, right? So this is something which I have taken as hx, where x is actually a feature vector defined by x1, x2, right? So now when you substitute these values for hx, for m and c in hx, what do you get? You get something like x2 minus, and since m is actually -1, you get +1. +1 multiplied by x1, so it is x2 plus x1 minus 90, right? Suppose tomorrow if you have a new test data, let me plot it using red color, and it falls somewhere here, assuming that its value is, test feature vectors value is, let us say, 2030 or 2012, right? If it is 2012 with a comma in between, because I am taking x1 and x2. So where will it lie? 20 and 12 will lie somewhere here. And you can understand that this point, which is the test feature vector, should belong to class A. How does it belong to class A? Then what are we going to do? Once the hypothesis is generated using the M and C values, I'm not asking you to automate this M and C computation. As a student, you are expected to know where to draw this line. Of course, there could be several different lines which would have created the correct answer, right? So any line could have been the correct one. So what I'm suggesting here is that this is the hypothesis which is constructed, which I have marked within this rectangle in red color. So once this hypothesis is made, how are you going to test, how are you going to classify this test vector? What will you do? You will say h of 20, 12, okay, that is what is the test feature vector. This will be equal to, then you substitute the values of x2 and x1. So what is x2? x2 is 12 in this case, plus x1 is 20. So what does it become? 32 minus 90. What is its value? This is, of course, less than 0. Because it is less than 0, you know that it is lying in this class, right? Lying below this line. And if it lies below this line, then our construction of the entire hypothesis, which suggests that anything below this line is belonging to class A. Okay. Now I am asking you to classify another test feature vector. Test vector, let us say is 100, 100 and say 40, even 140. Can you classify? Yeah. So can you classify this test feature vector 100 and 40? You can compute these values. What is the value of hx for this test feature vector? It is coming out to be 100. So h of x, or rather I should write it as h of 100, and 40. This is coming out to be something like what is it going to be? 100 plus 40 minus 90. So that is going to be greater than 0, and you know that this belongs to the second class. Now if I have the data which I just plotted, the training data, I'm marking the training data using this green color line. Fine. This is what is the training data. And now if I ask you to fit a line using regression, now I'm changing my entire domain of problem from classification to regression. What will be the new line? What you saw as a decision boundary is a line with a slope m equals -1. Now what will be your stand on deciding the line that fits this data? Then definitely I'm not having these classes. In the regression, there is no class information. There is just the x1 and x2 information. So if I have to still be more clear about what is there in regression problem, you will see that I'm removing, or I'm not including the class labels in this information. You can see this enclosure by this thick blue line. It is only the data x1, x2, no class label for regression. So had this been the case, then I'm removing slightly certain curves, okay, and I'm removing this decision boundary which I used for classification, and all the examples which I use for classification I'm removing, okay. So now how would I fit this? Even I'm removing this test data. Which line would fit it? Can you tell? So the line that fits is going through all these points, okay. These points, if this was the line, then we would have been the happiest, because this fits all the lines, and then the color of the points will also not be different, because we are not talking about class information now. So its slope, the slope would be somewhere around m equals 1, because it is a 45-degree angle kind of. You can always compute it. You can always calculate the angle. And whatever fits graphically, right now you have to understand the algorithm. Later on you can write your program that create some error function, which error you will be making use of some techniques like gradient descent algorithm to automate the procedure of finding the minimum error and the corresponding parameters later. But today the need is that you understand the procedure. If you have understood what it means by regression, you are actually trying to draw a line that best fits all these points, all the 4 points. I'm assuming that m was 1, right? If m is 1, then what is the equation of line? Assuming that it may go through the origin, then your equation of line will be x2 equals x1. This is only an approximate computation. I'm trying to just elaborate on the procedure. Okay, so if this was the case, then your hypothesis construction would be h of x1, x2. In the case of regression, I'm telling you. So I must write here, it is a regression case. Okay, so this will become this is actually going to be equal to x2 minus x1. Okay, so how will you predict the value? What will be the value? If suppose I want value to be predicted for x1 equals 50. So x1 equals 50, you get x2 equals 50. That is what is the kind of prediction that you have. So you must understand the problem specifications with regard to regression and with regard to classification. For classification, you are trying to find the boundary that separates the data points belonging to different classes. In regression, you are trying to find a line that goes through maximum number of points, or if it goes through closer to some points, the error should be the minimum, or the deviation from those points should be minimum. Yes? So is that difference clear? So okay, any more questions? Yes, classification is called as supervised learning. Okay, but clustering is unsupervised learning. Okay. So can I pick up some questions from the top, and then I will come to these questions. Okay. As far as the slide is concerned, this will be the part of the video, so you can always access these discussions. Okay. Yeah, decision tree is also a classifier, so it can be used in classification. But you know that the classification based on decision tree has its own limitations. That the unseen data cannot be classified by the decision boundary. Okay. Okay. Is there any question which I have actually not attended? Maximum likelihood of hypothesis, as we discussed in the Bayesian learning, what you do is you try to find the posterior probability using the Bayes theorem. I think you will go through the complete session and you will understand. And whichever is the most likely or more probable situation, that is going to be the consideration for us to label the class, as we discussed in the example during that session. Okay. Okay. Yes. So classification is just assigning class. Regression is predicting value for a given feature. You're right. Okay. Okay. Distance weighted nearest neighbor classifier. So distance formula is about you know taking this squared distance and its reciprocal. That will be the weight. Yeah. So distance formula you can actually calculate using the kind of Euclidean distance if the points coordinates are given, and if just the distance is given, then you can directly take the square, yeah, and take its reciprocal. Okay. So classification will happen after cluster. It is not necessary. Sometimes we just cluster together some data to understand their behavior. We need not even classify there. Okay. So what is the threshold in a linear equation classifying linearly separable data? Yes, it is the intercept. It is actually the intercept which has been imbibed in the equation of your decision boundary. Later, when we do neural network based classifiers, you will realize that this kind of constant is actually considered to be a kind of bias, and this bias is separate from what we did in yesterday's class. So that we will go for later. Okay. So any more questions? You can ask any other question if you have. So how to draw a scatter plot? A scatter plot basically is a plot representing the relationship between the features. So if you have data, having their feature vectors like f1 and f2, and then you plot, you will know their correlation. If they are heavily correlated, then selecting those two features may not be very useful for you to classify, because they are not providing any sufficient information more than what one feature provides to us, right? So a scatter plot is drawn between the features, and each point in the scatter plot is basically representing an observation. Will the numerical question specify which type of classifier to use for the solution? Are you asking about the exam? So yeah, the classifier requirement, if at all is there, that will be specified. Yeah, yeah, it will be specified. If a particular classifier is required to be used, then you will be given the details to answer accordingly. Okay. Yeah. Any more questions? Yes, exactly. The mid-semester topics will cover all contents which we discussed during these sessions. Okay, and then all discussion which we had either through our live interactions, or they were they were mentioned in the slides. Then you can read book chapters also to get some more depth of the understanding. But of course, the topics will be focused, and whatever contents we could cover in these sessions, they will be included. Yeah. Yeah. If a topic has not been discussed, it will not be there. All right. Um, as such, I think I could not find the link for the reference books because their e-book is not available. But I think we have that Indian edition available. Um, I could find out that these two books which I included in the handout for as a reference, they are I think in the range of 500 to 600, yeah. But do not go for Christopher Bishop's machine learning book. It is very, very costly, and its link has been given to you. I think some PDF link is available, so that has been given to you. Yeah. So classification is about identifying the class and label, and regression is about function approximation. Yes, yeah, you are right. Okay. And in both the cases, you are using supervised learning because you know either the label in classification case or you know the value in regression case. So basically, both of these are the prediction problems. In the classification, you are predicting the class label. In regression, you are predicting the value. Okay. So see, the reference books are available, and many of the things I have discussed in the class, it is all up to you to decide which book you want to purchase. Okay. There are reference books, there are textbooks. Textbooks links I have already given, and if you, uh, you have to decide which books to take. Yeah. So any more questions? So, yeah. So I think you can go through the lecture and find out the difference between bootstrapping and k-fold method. And initially you can go for the k-fold method, where you are actually dividing the data set and then you are trying to pick up one at a time for the testing. Okay. And read more on bootstrapping. That will give you some more idea. Any other question? Fine. So I'm closing this session. So I will be able to answer your queries if you post on your Takshila portal till 6th evening. Anything regarding sessions 1 to 8 will be answered only till 6th evening, right? Beyond which I cannot answer anything pertaining to the exam or questions relating to sessions 1 to 8, whether it is a regular exam or a makeup exam. So make sure that you study everything, and if there are certain doubts, you can post on the portal because we also have to maintain certain examination norms that close to the exam we cannot answer questions. So likewise, I will be available for answering your queries till 6th evening. That is, 2 or 3 days later. Till then, you can ask your questions. How do you expand the numerator? Um I'm not able to recall this because right now I don't have the slide. Um, you can post this on Nalanda. Otherwise, this one is actually a kind of posterior probability, the conditional probability x1, x2, xn given y, right? Into py divided by p of x1, xn. So this is a conditional probability. This is actually a kind of uh, formulation of the conditional probability. If you just reduce n to 2, try to look at it, or n to 1, you will be able to recall your high school statistics where you had p a given b multiplied by p of b divided by p of a, making it equal to p of b given a. So just try to relate multiple variables with the kind of understanding you had. This is basically a definition. Bayes theorem doesn't require a proof for its formulation right in the course on machine learning, right? It is only a formulation. You have to understand that x1 to xn, these are the variables whose probability in the joint sense or the joint probability is being tested when y is given. So it is actually the conditional probability for all these joint occurrences of x1 and x2 given y. And then that is how this formulation is being taken in the Bayes theorem. Basically, there is nothing to worry about. It is a generalization of the Bayes theorem rather, with more variables. If you confine to some two variables, you will get the similar equation as you had in your high school maths. Or if you have further doubts, you can post your query in the portal. Fine. Okay, so best wishes from me for your exams, and continue study and do well in the exam. All the best.